So I'm trying to measure variability. And to measure variability, I'll start with some data that is distributed along a line. Okay? So I have all of these data points. Think of this as a dot plot. And now, if I look at this, this is the highest value, this is the lowest value. They seem to be somewhat equally distributed. Perhaps here we would have the mean of the sample values. And then if I would like to know the variability of a specific, the measure of variability for specific points or for all of the points about this, one thing that I could do, let's say for this value, is to capture the distance that it is away from the mean, right? So if this is my x1, it could be any number, it could be any xi, but I'm picking this one and I'm calling it x1. And I look at that difference, or sorry, that distance. One way that I can measure that distance is to say x1 minus x bar. Yes? And I will have a measure of how far this point is from the mean. I could do the same thing for all of the other points, namely this one. And I'm just going to call this one xi. Now, if I do the same thing and look at the distance, here I would have it xi minus x bar. Okay? Now, if I do this for every single point, I would capture each individual distance of every individual point from the mean. And if I add it all up, I would have a global measure of variability, how far each point is from the mean, right? What would that be? What would that measure be? Well, if I do it for every point, for the first point it would be this, for the ith point will be that, but for the second point it will be this, right? The third point would be the same, and the last point would be that. Now, this is the variability for each point with respect to the mean, correct? But I wanted a global measure of variability, so I can add it all up, and which I will do. And if I add it all up, I have a sum from x1 to xn given by these data points minus n times, because I have n points, yes, n times the mean. Well, I know I have the formula of the sample mean because we just worked out this earlier. And so I can substitute it in this equation. Minus n times the formula for the sample mean, which is nothing more than the sum from x1 until xn divided by the number of data points. Right? Well, if I work out by dividing these factors, I come to the conclusion that my overall measure of variability is zero. So yes, we're capturing variability about each data from the mean, but if we don't square it or cube it or look at the absolute value or so on, well, then we would get a measure that would be zero. Instead, by squaring it, we penalize some of the distances, the further away, and we can add it up such that we obtain something that is not zero. Now, when we do this, we avoid a problem, but we create another. We avoid the zero, so the measure of variability is meaningful, but then we have units that are squared. All of the units are squared. So $, and so on. And we come up with the value that frequently enough is large in comparison with the data that we're using and the mean of the data and so on. So one possibility, one logical step is to take a square root. And we actually use it so much and it's so meaningful that we give it a specific name, the standard deviation.